Welcome to a lesson with Dr. Powell. Let's take a look at writing a function f of x is equal to 1 over x as a Taylor series with center 1. That means that we're going to have powers of x minus 1 throughout the series. Okay, we're going to use the idea that the coefficients can be determined or found using this idea of taking the nth derivative, plugging in the center value, and dividing by n factorial. All right, so let's get started with that. We need to come up with a pattern for the nth derivatives with plugging 1 in. So let's take a look at our derivatives of 1 over x. Okay, we take n represents which derivative we take as well as which power we are in our series. Our series has this form, and this is the same as this, which is the same as this. In particular, when n is 0, that means we've taken no derivative, so it's just the function, 1 over x. Next, 1, we have negative 1 over x squared. 2, we take the derivative of this. So this is, remember, this is negative x to the negative 2. So think multiply the negative 2 down. That would be positive now. And it would be 2 over x cubed. Next at 3, notice that this is going to be 3 times 2 with a negative all over x to the 4th. And at 4, we're going to have positive 4 times 3 times 2 over x to the 5th. Notice the pattern of what's ensuing. It looks like we're getting some factorials. In fact, this is matching n. So it kind of looks like, generally speaking, we have n factorial on the top. We have x to the, this is 1 more than the n value. So x to the n plus 1, and then we're multiplying this by negative 1 raised to the, we're multiplying this by negative 1 raised to the nth power. Now, looking at this, maybe I don't want to put x in here because remember what I'm plugging in, and it won't plugging in because our coefficients are going to be constants. They're not going to depend on x. So you better not put an x value in for this. That would just be incorrect. So what should this be instead? We need to plug in the center. We plug in the center is 1, so we plug in 1, and notice it's just 1. So it looks like our coefficients turn out to be negative 1 to the n times n factorial. All right. Now we're not quite done because we take this and we need to divide it by n factorial, because all we found right here was the nth derivative evaluated at 1. So we divide it by n factorial. And notice we just get negative 1 raised to the nth power. Okay, so negative 1 raised to the nth power would be our coefficient of x minus 1 to the n, and we are done. So this is n equals 0 to infinity of negative 1 to the nth power times x minus 1 to the n. Thanks for watching.